Hello, dear students. After the break time, then, let us continue. Just before the break, we studied on this example. Here on this worksheet, it is from worksheet number 13, the first pictorial drawing. It corresponds to the, like a photograph, the pictorial figure of an object. It's a right composite prismatic object. Studied on this example using two-dimensional tools of AutoCAD, just to see not only one view but more views, how not only front but also top but also left side view. Say in short, multi-view projection can be drafted, projections can be drafted using the two-dimensional tools of AutoCAD. The answer to this question is just to say very similar to the things to do in hand drafting. Using two-dimensional drawing, two-dimensional part of AutoCAD, the things to do are very similar to the ones, similar with the ones in hand drafting. In hand drafting, we use pencil and rulers and a real paper. It is working carry of a real paper. But in AutoCAD, along the home ribbon, find the line creation button, draw the lines. How? Creating. Indicate the starting point, indicate the ending point. How you can see where is the starting point, where is the ending point? For multi-view projection, remember the things in the previous classwork. Sufficient to talk about how the multi-views are created, are drafted in using the two-dimensional part of AutoCAD. Well, we mark the images of the characteristic points using transfer lines. Well, for instance, here from the pictorial figure, say that this is point A. Okay? Or point B, or whatever it is. I identified, to make it clear, while I'm talking about such things, I mean which point. I identified the points using the letters of alphabet. For instance, point A. Now, the front view of point A is over here. It is at the intersection formed by this transfer line and that transfer line. And since the top view is the other side view of the same object, so if the point A is over here, then it is top side view must be along the same transfer line. It is a mess because front view and top side view, between them, use the x-axis of the coordinate system commonly. Since the x-axis is commonly used by front by top, then the front view and the top view, okay, to it is all the characteristic points and the corresponding abscissa values must be consistent. If the abscissa for this point, it is the front view of point A is equal to, for instance, a certain millimeters, okay, relative to the origin of the coordinate system, then it is top side view must use the same abscissa value. Creating such a transfer line, we guarantee to have the images, okay, of the object as consistent with each other. Yes, and for instance, here for point P, Q, R, and this corner point, the altitude values are the same. They are all at the bottom side of the object, on the bottom side surface, so their altitudes are the same. So while creating a transfer line, here it is, then this means we mark the altitude value for all of such points, not only on the front view but also on the left side view. Yes, previous class time, the corresponding video record, okay, I already talked about one more time the advantage of using transfer lines. Yes, two-dimensional drawing. After having the transfer lines and at their intersections, marking the images of the characteristic points, the rest, start the line drawing process and join the characteristic points to each other. You know the geometry, you know that over here there is such a vertical line, there is such an inclined line as the corresponding image of the entities of the object. Yes, now, but here in this video record, one more time, I'm going to demonstrate how the views are created. Now, be careful, I'm not saying drawing, but creation, using the 3D part of AutoCAD. First, it is a must, have the solid model of the object, and then view creation is an easy cake. Using clicking on layout tab and then writing base view command, view base creation command, and then go ahead. Well, to the end of this class work, I'm going to one more time demonstrate how the views are created in AutoCAD. Not drafted. For drawing the views, yes, transfer lines and then coordinate axis, transfer lines, and then join the characteristic points, images of the characteristic points, etc. Well, such a view drawing issue may take minimum half an hour, even for such a simple geometry. But if you have the solid model of the object, then view creation may be ended in a few minutes in AutoCAD, 1 minute in Inventor. Okay, but say first create the solid model of the object. Okay, well, I think it's okay, no need to see my face. While closing the camera can decrease the size of this video film. These are the views, so format is important. Well, transfer lines are in transfer line layer, turn the length of it and then hide them. Visible lines, why? Because the lines correspond to the images of observable entities, directly observable relative to the observer. And if there is a hidden feature, yes, have it in hidden layer. Okay, so well, using the two-dimensional part of AutoCAD, yes, necessary to use more than one pages. Some of them, one of them is to have the symmetry axis, the other have the projection of hidden features, the other have the projections of visible features, the others construction lines, the others keeping the transfer lines, and so on and so forth. But if you're going to use AutoCAD, starting from the sketching stage for 3D model creation purpose, then well, no need to have such layers. Using the automatically activated layer, one of the layers, can draw the necessary sketch and then apply the solid model creation process. Okay. Now, remind you, previous video record and the corresponding class time, I said that if the object is a right prism with flat surfaces, the measure of the surfaces are flat, and the part of the rectangular prismatic stalk to trim is to its volume smaller than the total volume of the object, then yes, in the technology, the cutting method is recommended. Applying this method in real life, from the stock, from the market, we find a rectangular prism. It is minimum to be in the overall size of the object. Okay, and then, well, after taking such a rectangular prismatic block, put it onto the table of the shaping machine, and then cut the unnecessary parts, trim the rectangular prismatic block, and set the shape of the object. In real life, yes, rectangular prism and then trim, cut this part, have this channel. Cut the material, create this surface, cut the material, create that surface, you know. In virtual environment, well, it is very similar. First, create the model of the rectangular prism using the overall size of the object, and then, well, draw the sketch, have the profile, apply the process, and cut the material. Okay, studying on this example, one more time you're going to see how the model of such an object is created. Okay, although I'm going to talk about specifically on this example, but the things in my method are in general applicable not only for this geometry but the geometry of the other objects. Okay, the only measure is that object is a prismatic object. It has flat surfaces, and the volume of the part which is to be removed, to be trimmed, is less than the volume of the object in its final form. Then in real life, select cutting process. In virtual environment, yes, similarly have the empty spaces or create the surfaces using the tools of the software via cutting the unnecessary parts. Okay, then start. Open AutoCAD. Yes. Instead of using my template, because no need to have more than one layers. Okay, just start from the beginning. Click on New File Creation button. Okay, from Light Background folder, select this template, ISO template option. Click on Open tab. And then, well, in AutoCAD have an unlimited environment. At present, it is two-dimensional, XY. Plane is coinciding with this page. Okay, unlimited. Well, I know from the worksheet the rectangular prism to create, it corresponds to the stock to be purchased from the market, is to be 100 by 50 by 65. Okay, this arrow says that the observing the object in this direction can output the front side view. It is the observation direction. So this means that is the front side of the object. Then surface EFQP, surface HR, this corner has not been identified, IH. These are the frontmost surfaces. Okay, if this is the front side, then 100, it is the shortest distance from the left side to right side, will be the width of the object. 50 is the depth of the object. It is the shortest distance between the most front and most back surfaces. And 65 is the height. So, well, the stock is to be in this overall size, 100 by 50 by 65. I'm going to draw a rectangle as the first sketch and consider that rectangle as the bottom side surface. And in applying extrusion process, I'm going to create the rectangular prism. It is extrusion length, height of the prism will be 65. Okay, then do it. Still, I can use 2D or just, well, change the mode from 2D to 3D. First sketch may be drafted in 2D mode or 3D mode, which one you like. But the other sketches are to be created, drafted in 3D mode, in 3D environment. So without forgetting, I'm going to change the mode from 2D to 3D. Click on the switching button and then select 3D model option. Yes. Now I have different things along the ribbons. One more time, anchor the command bar to the bottom edge. and then start rectangle creation process. And then system asking me where is the first point. Well, it is not going to be the view. Okay, it is just the sketch. Thereafter to apply the model creation process. So starting point is not so important. Arbitrarily make a click. And then move the cursor diagonally. Well, still the coordinate axis, you see x-axis is in the horizontal direction. Well, I'm still seeing the things two-dimensionally. And xy plane, x-axis is in the horizontal direction right now. And it is positive side extending to the right. Y-axis is vertical and it is positive sense in the up direction. This is important because for the second corner point, system asking me delta x delta y value. Yes, because if dynamic input button is on, this is along the status bar dynamic input enabling or disabling button, it is on. If it is on, then second point, following point requires relative coordinates with respect to the first point. Now I am sure AutoCAD just going to consider the written number into the second box along the train as delta x and the other number delta y. Delta x delta y are with respect to the first corner. If you're going to create the rectangle as the one extending to the right and in the up direction, then delta x positive, delta y positive. But if you're going to create the rectangle, say in this direction, downwardly extended, then delta y must be written negative. Yes, also from the third box, you see when I move the cursor, not higher level but lower level, AutoCAD knows that the point is relative to the first one at the negative side of the y-axis. So you see the number is a negative number. So it is important relative to the preceding mark point, then be able to write the x and y values for the following point, for the second point. Here I know that since this rectangle in my mind is the bottom side surface of the object, and the second point, distance between the first corner and the second corner, it is just about to be located in the space, uses in the x direction 100 millimeters. Relative coordinate for the second point with respect to the first is 100. Shall I write it as positive? Yes. If it were the case opposite, then if the rectangle is to be created as extended to the left, then I would write the value as negative. But it is positive. 100 is the order, width of the object. And since it is the bottom side surface of the prism, it is the width of the rectangle. Okay. Click on comma key and into this box write delta y value. Okay. Delta y, since my consideration it is the bottom side surface, corresponds to the depth of the prism. It is 50. Write 50. Press enter. Here is the rectangle. It is relative to the size of the display screen, maybe small or very big. If it is small, you can scroll the wheel of the mouse and then zoom in, zoom in. If it is too big, zoom out, zoom out. Or to be able to see the sketch in almost in the size of the display, you can write this comment, zoom, okay, press enter, and then click on down direction key, and from the list you see whenever there is a little arrow within the first compartment, this means you can find some options. Click on down direction key of keyboard, and from the list of the options select all option. This is to say that fit the existing figure, okay, as fully matched to the screen, to the monitor. How you can do it? Clicking on along the navigation bar, zoom extends button. Rectangle is at such a place and its size is not proper, but clicking on this one, zoom extends, I can have the already drafted sketch in full size as matched to the screen. You know this. But this is more practical. Scroll the wheel, zoom in, zoom out. Okay, and then after having the first sketch, then for my convenience, I'm going to tilt this drawing. I can do it clicking on the corner of the orientation cube or cutter symbol. Okay, and see the third axis, z-axis. Now xy plane is just the plane in which I have this rectangle, and in the z direction, yes, I have this worksheet, this pictorial figure on the worksheet. Okay, I'm going to create the prism first, rectangular prism. Here, of course, to be able to see the dimensions while I'm going ahead, passing to the stages, well, I am in AutoCAD environment, I forgot the number, I forgot the shape. Okay, then, since I have only one monitor, select the worksheet icon, click, and then see the worksheet, and then turn back to AutoCAD. I don't want to make such switchings. So you know my technique. I already take the print screenshot, and in Paint program, you know, previous class work already changed the format from HTML to picture. I am sure in the memory of my computer I have that picture file. Yes, this is the address in the memory of my computer, and that is the picture file. Right click and then select copy option from the menu, and then in AutoCAD can paste it as if I had two monitors. Okay, if the mode is 3D, along the home ribbon cannot find clipboard panel and then click base, don't worry about it. I know drop down menu bar, I can find the same option to start the pasting process. Clicking on this listing arrow, and from the list selecting the second option from the end of the list saying show menu bar, I can have drop down menu bar. Along the drop down menu bar, it is the option, edit option, drop the list, and then say paste. Okay, I'm going to paste the screenshot over here, arbitrarily indicated. That is the anchoring point. Press enter twice. Here is the worksheet, but since I tilted the sketch isometrically, well, couldn't find this picture in a suitable inclination or orientation. It is just if I see the things in this direction two-dimensionally, well, it is just a suitable pictorial figure. But observing it is in this direction, it is not so readable. Be aware, can rotate it. Apply rotation process, 2D rotation. Indicate this one. Press enter and then rotate it about such a base point. If you rotate it like this, then check whether it is more proper, more readable, more distinguishable. If you still say no, then rotate it in not only in XY plane but in 3D space using this not 2D rotation tool but 3D rotation. Click on this and start the process. Indicate the frame of the screenshot as the say that it is the entity to rotate. Press enter and then you know this simulation. 3 rings, 3 orbits. Okay, if I select one of them, clicking on this ring for instance, yes, it is axis will be simulated in the screen. Shall you rotate the selected thing about this axis, or about the axis of this ring, or about the axis of that ring? You should know, of course, or try. I'm going to rotate the screenshot about this axis. So, okay, rotate it like this. If you say that, yeah, it is more proper, then continue. If not, then make one more trial. Okay, from here I can see the things. It is suitable for me. This orientation is suitable for me. If not, then apply 3D rotation again. Now, this is the profile. I am sure the bounded area by the rectangle is a closed profile and it is ready, okay, it is a region. No need to apply region definition process. Okay, if the rectangle created, okay, line by line using piece of line facility, then yes, it would be a mess to apply region definition process. But since I created this rectangle using rectangle creation tool, it is okay. The surface bounded by the rectangle is a region. Can directly apply extrusion. Okay, started the extrusion process. Indicate this sketch with clicked at any point along any boundary. Press enter. And then yes, the prism, since I said that the sketch is the bottom side surface of the prism, then create the prism in the Z direction, positive direction of the Z axis. The value is 65. Right, and press enter. Here is the model of the stock. Okay, I can make it more realistic, selecting the visualization style, for instance, conceptual. Yes, it is a box. And then after having the model of the prism, a rectangular prism of course, say that as if you took it from the stock, from the market, and it is the time to cut the material. Cut the material, trim the unnecessary parts, and then finally have the object to its necessary entities features. Okay. Before going ahead on the rest, well, without forgetting, for the first time, save this in this for this studying. For the first time, save as. If it is the first saving stage, you know, need to select save as option. By the way, whether I am recording, yes, I am recording all the things. Good. Save as, and address, check the address. Well, show the address. I'm going to save it in this folder, this subfolder, and then generate the name for this file, surname, ID number, section number, and then this is the example which we selected it from worksheet 13, WS13. Okay, and then here in this example, it is not two-dimensional drawing issue, it is model creation issue. So I'm going to write this word model. Okay, solid model. Date of today, 24th of April, April 24. Okay, and then continue. Now here in my method, after having the rectangular prism, yes, now the example, selected example is the same here. In my lecture notes, I use this model, remember, first quadrant, third quadrant. And well, this is the object. Software here, by the way, is Inventor. I have the model of the object already created. Okay, I'm going to use this model to explain the things much more clearly, easily, and for you clear enough. In my method, after having the rectangular prism and saying that it is as if the stock you purchase from the market, then to be able to create the entities of the object, okay, select one of the surfaces. I selected this surface. Or if you want, select this surface first, or select this surface first. Select one of the surfaces of the object. That surface has not been created yet. what we have a rectangular prism. Yes, here it is. That surface not created yet. And then, in my method, after selecting the surface, ask this question. That surface is perpendicular to which principal side? This surface is perpendicular to profile side of the object, so correspondingly perpendicular to the profile picture plane. Okay. So since it is perpendicular to profile side, profile picture plane, obvious that while we're observing the object in the direction to obtain its profile view, that surface will appear to its edge. Well, I mean, in my lecture notes, there are some flat surfaces on the slides, and it is one of them. In the first quadrant, yes, this is the surface. Well, that surface in this example corresponds to that inclined surface. Okay. Since this surface is perpendicular to profile side of the object, after saying that this is the front side, then this is the profile side. This surface is perpendicular to the profile side. So, since the profile side of the object is parallel to profile picture plane, this means that surface, similar to here, perpendicular to the profile picture plane. So while we're observing the surface in the direction sending the rays of sight orthographically with respect to profile picture plane, we see the projection of that surface in form of such an inclined line. Okay, if a surface is perpendicular to the picture plane, then its image is called H-view line. H-view. Okay, in my method, yes, after selecting the surface to create its model via cutting the material, then first see that surface is perpendicular to which principal side, which principal picture plane. This is perpendicular to the left side surface, also right side surface. So in my method, after answering that question and saying that it is perpendicular to the left side surface, then over the left side surface, draw the necessary sketch for having the region to indicate thereafter to apply the process, cutting process. Okay, over the surface, the necessary sketch uses the edge of the surface, that surface it is to be created. What I mean, on the surface, left side surface, draw a line. It corresponds to the edge of the surface, which is the surface which I selected to create its model. Okay. And then over the surface, draw the H view of the surface. And then to be able to have a closed region, closed profile, draw the other boundaries. And thereafter, apply the extrusion process. Yes, I'm going to do such a thing. Obey to my recommendation. Well, I know that this is the left side surface, and the edge of the inclined surface, it is boundaries EF, FG, GA, H, AH, I, J, K, D, B, E. That surface is perpendicular to that left side surface. So on the left side surface, by drawing the edge of the surface and adding the other boundaries, can have the necessary profile. Since I'm going to study on this surface, in AutoCAD, unfortunately, XY plane is to be brought as coincided with that surface. Okay, you know how my favorite method to bring the coordinate frame to a suitable place to have XY plane coincided with the surface on which need to draw the necessary sketch, need to draw the sketch. I use this tool, 3-point tool. Clicked on this, start the process. It is for moving the coordinate frame from word location to suitable location. Well, since I'm going to study on this surface, I'm going to locate the origin at this corner or at the other corners, but on this surface. Okay, this is the first point. It is to indicate the origin. And then say that the x-axis is to extend in this direction if I show a characteristic points, thanks to snap enabling of course, at this corner, can say that x-axis passing through this point to its positive side. Okay, and then indicate this corner snapping to say that it is one of the points along which y-axis passes through. Yes, and then yes, using indicating 3 points, first origin and then point along the x, point along the y, you see I managed to bring the xy plane to the correct place. XY plane is coinciding with this surface, so whatever I draw, it is going to be in the plane of this surface. Okay. Here, to be able to obtain the edge of that surface, saying that surface, I mean one more time indicate this inclined surface. Yes, well, the lower boundary of the inclined surface, this is one of the lower boundaries, the other boundary is over there. Okay, from the pictorial figure, I know lower boundary of the inclined surface from the bottom side surface 15 millimeters away. Upper boundary of the inclined surface from the back side surface of the object 15 millimeters away. I know this location, the dimensions. This 15 is to locate the terminal point of the edge of the surface with respect to bottom side, and this one 15 is to locate the other terminal point of the edge of the surface with respect to back side. 15, 15. Okay. So, to be able to have the edge of that surface, edge view of the surface, start line drawing process. Of course, to be able to have the profile as a region, no doubt, for my convenience, not single line, but polyline option. Select polyline, start the process. The terminal point, it corresponds to the image of EF, boundary EF. Yes, is at the place where along this edge, okay, but 15 millimeters away from the bottom side. Since the origin is just at the bottom side surface, on the bottom side surface, so I'll write the coordinates for the starting point to have the edge of that inclined surface. Yes, abscissa value is 0. Clicked on comma key. Ordinate value, you know, where is y-axis? Y-axis is over here, according to right. Well, since the y-axis is in the up direction and my purpose is to mark the point relative to origin at a higher level, ordinate value must be written as positive 15. Press enter. Yes, now that is the starting point. And then the ending point for the edge of the surface, yes, it corresponds to the image of line DK. Okay. Well, relative to this origin, write the coordinates. Well, don't forget, not relative to origin, sorry, relative to the preceding point. Since dynamic input button is on, don't forget, for marking the first point, yes, we use XY values, but for marking the second point, following points, write the coordinates relative to the first point, relative to the preceding point. Well, relative to the preceding point, the abscissa value for the terminal point is 50 minus 50 is the depth, 50 minus 15. Since the upper boundary with respect to backside 15 millimeters away, so the coordinate of the terminal point of the edge of the surface with respect to that available origin yes, since the point is at the positive side of the x-axis, delta x is positive, write the value 50 minus 15, it makes 35. It is positive. Write 35. Although right now in the simulation, from the simulation I see that AutoCAD using its default setting ready to gather the length of the line and the inclination angle. I don't know the length of the line, length of the edge of the inclined surface. I don't know its inclination angle. But I know the terminal points of its coordinates of its terminal point. Okay, one coordinate is 35 positive. It is delta x value. Clicked on comma key. The other point, delta y. Delta y 65 minus 15. 15 is the location y value, location dimension for the starting point. Okay, the first terminal point. So relative to that point, the coordinate of the ending point is 65 minus 15. It makes 50. Write 50. Positive, negative, positive, because the point is at the positive side of the y-axis. Delta y is positive. Write 50 and then press enter. Here is the inclined line. You see, managed to create it. And then to be able to have the closed profile, then polyline process still in execution. Snap this corner, have such a boundary, and then snap the starting point, have the other boundary. Press escape button. And then if I change the visualization style, you can much more easily see what I have. Yes, I have this triangle. Yes, the main part of the triangle, this inclined line, corresponds to the edge of the surface. It is this surface, while observing the body as if in this direction I see it is edge. The drafted line in my consideration corresponds to the edge of that surface. Okay? And the other lines, yes, to have the profile as a closed profile. Okay, and then the rest. Apply extrusion process. Indicate this profile with a click, press enter, and then, well, create a rectangle, create a prism. Yes, in AutoCAD, cutting is not direct. First, create a solid feature, and then perform subtraction. Well, the length of this triangular prism should be minimum 100. To be able to much more easily indicate it, I am going to furtherly extend it, have such a further extension. And then, yes, the rest. To be able to allow you to see the things what we have, select conception option. Yes, a rectangular prism and triangular prism. If I subtract triangular prism from the rectangular prism, then this means I achieved to create the inclined surface. Subtraction process, indicate the main part, press enter, don't forget to click enter, indicate the triangular prism, click, don't forget to press enter. Yes, you see, achieved to create the inclined surface. Save the file one more time. And then, how about the other surfaces? Now, in the order, I selected this profile, say this trapezoidal surface. It is an inclined surface. Well, here the model see this surface, and it is symmetric copy. Object is symmetric. Well, we have at both of the corners here and there inclined surfaces. Now the question, those surfaces are perpendicular to which principal side? These are perpendicular to the back side of the body. So, well, the H view of the selected surfaces ought to be drafted on the backside surface. Why? Because while we're observing the object in this direction, okay, the edges of the surfaces, trapezoidal surfaces, would appear like this, like that. Okay. So in AutoCAD, yes, rotate the model I'm going to select free orbit option and then freely rotate it to be able to allow myself to see the things, okay, on the back side. Yes. On this surface, I'm going to draw the edge of the trapezoidal surface. Well, rotate this model, picture. Try to use 3D rotation tool. It is, you see, not so good to its orientation. So I'm going to rotate it. About which axis, if I rotate it about which ring, the axis of which ring it can be more proper for my studying. Maybe this one. Okay. Rotate it little bit more. Is it more readable? If not, then rotate it about this axis. Oh no. Well, I think this is now better. Okay. Press escape button and finish the rotation process. Yes, now I oriented the screenshot as more proper for my studying. Now the edge view of the trapezoidal surfaces are to be constructed on the backside surface because those surfaces are perpendicular with respect to backside. Well, XY plane must coincide with the backside surface. So one more time, apply moving process for the coordinate frame. 3-point method is my favorite method. I clicked on it. I'm going to locate the origin to this corner. Okay, x-axis, that corner, I'm going to indicate that corner as the point through which x-axis passes. And then y-axis, directed as vertically oriented, indicating this characteristic point to say that y-axis passed through. Yes, you see, I managed to bring XY plane onto the backside surface. So, can start drawing. The edge of the trapezoidal surface, lower boundary, 15 millimeters away from the top side surface. Okay, upper boundary relative to the profile side, 20 millimeters away. Okay, so 15 and 20 are the coordinate values. For the inclined line, say here, corresponds to the edge of the trapezoidal surface. Okay, origin is over here. Relative to the origin, 20 is the coordinate of this, 15 is the coordinate of the other. Okay, so similarly start a polyline creation process. And then, well, I'm going to mark the lower point, lower terminal point. It corresponds to the image of NB. Okay, so for this point, abscissa is 0, right 0. Clicked on comma key. Ordinate, since y-axis is in the down direction and the point relative to the top level, most top level is at a lower position, 15 is positive. Y value, delta y is 15. Write 15, press enter. Yes, that is the starting point. And ending point corresponds to the image of MD. Yes, for this point relative to this origin, it is, at that corner. Abscissa value is positive 20. Clicked on comma key. Ordinate value, yes, 15. Delta y is 15. But since this measurement is in the negative sense of y-axis, 15 must be written as negative. Minus 15. It is important. And then press enter. Yes, you see, managed to have the edge of the surface. this inclined line corresponds to the H view of the trapezoidal surface. And then the rest, to be able to have a close profile, snap this corner, snap the starting point. Press escape button, finish the polyline process. And then, yes, the necessary profile is over here. The rest is extrusion process. Applying extrusion process, since we don't know NB is unknown, well, the thing to do is that create the prism, triangular prism, okay, little bit arbitrarily in length. It should be greater than the order of NB. Well, if I furtherly extend the prism, then, well, can guarantee to have the surface in the correct size. Apply extrusion process and then indicate this profile. Whenever you encounter a difficulty while trying to indicate the profile, the other things will ready enthusiastically snap the cursor, so couldn't indicate the profile as separated from the others. Then, change the visualization style, wireframe. Much more easily you can indicate. Extrusion process. Yes, you see this triangle is easily indicated. Click and press enter, and then, yes, I'm going to create this prism with such a further extension. That is it. I don't know the total length, but I know that this surface is truly extending, so I arbitrarily extended the triangular prism. See the visualization style, change the conceptual. Yes, there is such a prism. And then, yes, let's subtract this prism from the main part. I know, to be able to have the trapezoidal surface, subtraction. But since I know that there is a symmetry here, well, if I create the mirror copy of this prism, instead of trying to draw the polyline at this corner, it may take greater time and effort. Well, I'm going to use mirror copy technique, because this trapezoidal surface is the mirror copy of the other one. Okay, mirror copy process. Expand the modifier panel and find the process button. Click. I started mirror copy process. System asking me which entity, the copy of which entity, this triangular prism. Indicated with a click, and then say press enter. Indication stage is endless. Need to click enter key. And then mirroring line. AutoCAD asking where is the mirroring line. I'm going to indicate the line. It passes through the midpoint of this upper boundary, midpoint of the lower boundary of the backside surface. Of course, I already enabled my system to indicate midpoints. Yes, for midpoint there's an enabling. So I can indicate the midpoint, indicate the other midpoint. I said that it is the mirroring line. Indicating 2 points can define a line. It is the mirroring line. After creating the mirror copy of this prism, I'm not going to delete the other. So the answer of this question is no. And then the rest. After having the triangular prisms, yes, the rest is subtraction. Time to subtract. Okay. Yeah, well. Oriented like this. Subtraction. Main part, indicate, press enter. And then this, indicate, that, indicate. Press enter. That is it. You see? Managed to create the trapezoidal inclined surfaces. Yes, save the file one more time. And then orbit. Yes, now the time to create the channel. Yes, this channel. The surfaces of the channel, yes, profile surface, frontal surface of the channel, are all perpendicular to bottom side surface. So my method, first question, the surface which you selected to create it as model, applying cutting process, extrusion cutting process, is perpendicular to which side? The surfaces of the channel are perpendicular to the bottom side. Okay, and the edge views of the surfaces are to be sketched out on the bottom side surface. Since this example, the surface of the channels are perpendicular to each other, instead of drawing polyline for having this, for having this, for having the third, I'm going to create a rectangle because the surfaces are perpendicular, and observing the object in this direction, for instance, I see the edges of the surfaces just perpendicular to each other. To be able to have a closed profile, need to have such a closing boundary. So it is going to be as a whole a rectangle. So to be able to save time, instead of drawing the edges of the surfaces of the channel line by line, I'm going to create a rectangle. This is my plan. Okay. Yes. Bottom side surface enable you to see the bottom side, rotating the model. Okay, see the bottom side surface. Okay. Yes. And then, since I'm going to draw the edges of the surfaces of the channel on the bottom side surface, I know XY plane must coincide with the bottom side surface. So one more time, apply move process for the coordinate system, coordinate axis. Well, I'm going to define this point as the origin, and then say that this is the point along which the x-axis passes, and this is the point indicate this, snapping this corner. It is the point through which y-axis passes. So, well, I am sure this is the bottom side surface, and over the bottom side surface, yes, I have XY plane. And then start the rectangle creation process. I know the size of the rectangle and its location relative to the origin. Okay, the coordinate of the corner of the rectangle is 25. Okay, width of the rectangle 100 minus 25, 50, and the other dimension of the rectangle is 20. Okay, so well, start rectangle creation process, and system asking me for the first point, first corner along this boundary of the bottom side surface. Okay, its abscissa is 25 relative to the origin, 25. Clicked on comma key, ordinate is 0. Press enter. And then gonna create the rectangle in this direction. Well, delta x, right now write the coordinate of this other corner with respect to the first corner. In other words, delta x. Since the second corner uses the positive side of the x-axis with respect to the first corner, write delta x as positive. It is 50. Clicked on comma key. Delta y. Yes, since the second point is at the positive side of the y-axis, so delta y is positive. How much? 20. Okay. And the z value, of course, it must be written as since unexpectedly I had the fourth box. Well, clicked on comma key and write 0 into that box, because z value is 0, because, well, the sketch is on XY plane. Z value is 0. Press enter and create the rectangle. I don't know why I had the fourth box. Okay, by mistake I think I made one more clicked. Okay, now I have the necessary rectangle, it is the necessary profile, and then apply extrusion process. First create a rectangular prism and then subtract. What should be the length of the rectangular prism? Minimum in the height of the, whatever the height of the channel is, then the length of the rectangular prism must be the same. But since I don't know the length of the channel, you see, length of channel, height of channel AC is unknown. I'm going to use this technique, create a rectangular prism with further extension, and then apply extrusion process. And then apply subtraction process. See how extrusion start the process and then be able to indicate this profile. If there is a difficulty in indicating the profile as separated from the rest, then change the visualization style from conceptual to wireframe. But here you see from the simulation, I'm ready to indicate the rectangle as the profile with a click. And then press enter. Well, I couldn't indicate it because it became a highlighting. So, well, oops. I'm going to change the visualization style. Yes. Extrusion process. Indicate this rectangle. Press enter. And then, yes, create the rectangular prism with further length. Okay. Into the atmosphere, through the atmosphere, from bottom side surface to a higher point. Okay, create the rectangle. The length of the rectangular prism is not so important, but it should be higher than the order of the height of the channel. I am sure if I create it with further extension beyond the limit of the prism, can create the channel via subtracting. And then, well, see the things more realistic. Yes, there is a rectangular prism and the main part, the rest is subtraction. Clicked on this and then say that from the main part indicate, press enter, subtract this rectangular prism, indicate and press enter. That is it. Here is the model of the object. I use this screenshot, no need to keep it. Thereafter select and push delete button. Save the file one more time and then make it solid model. It is now the model of the object. Since the material has not been input yet, cannot say solid model. Make it solid model. Along the parametric, visualization ribbon, visualize ribbon, can find the push button to bring the material selection assigning dialog box, material browser. And then, well, from this list select metal option. And then in this example, the model is, object is made of brass, polished brass. Clicked on the left button of your mouse while you're holding it as pressed, drag the mouse. You know, it is the procedure. It is as if take the material and then spread it out. Okay, throw it away toward the body. Release the button. That is it. It is the procedure in AutoCAD. And then, well, since the visualization style is conceptual, not realistic, it is not in the color of that material. But if I select shaded or realistic, then start seeing the model of the object in the color of the selected material. Okay, yellow brass. Save the file one more time. Now it is in perspective appearance. It may be misleading. Well, to be able to see the things orthographically, right now, for instance, in Inventor. Normally, Inventor selects orthographic orientation option and enables us to see the model orthographically. Here it is in isometric position, but orthographic viewing. Okay? Well, here in Inventor, there is one more option, orthographic perspective. If I select perspective, then you see, although the height at this part is the same that of the opposite side, it is, you see, diminishing. Okay? Toward the vanishing point, it is decreasing in size. It is perspective appearance. You see, perspective. It is not so good for engineers to see the object perspectively, so we'll select orthographic observation option. And similarly in AutoCAD, yes, it is in perspective mode. Write this comment to be able to see the model orthographically. Perspective. While you're writing the word perspective, can find this word, keyword in the list, select it, and then into the box, second box. Well, if the parameter is 1, you see the model perspectively. If you write the parameter as 0, press enter, you see the model orthographically. This is more suitable for engineers. Save the file one more time. And then, well, view creation is not a new thing, but say just to make a highlighting that after having the model view creation, yes, I'm saying not drawing, creation is an easy cake. You know, previous classwork, to be able to reach to this end, we use in the order of more than half an hour. At the background, we have transfer lines, etc. Lots of lines, tedious work. And mental interpretation in mind is necessary to be able to determine the image of point A, the image of this terminal point. Remember, if you watch the previous video or film, you can see my interpretation to determine the location of A, location of B. Okay, I solved the problem graphically. And I used almost 1 hour. But after having the solid model of the object in AutoCAD, view creation will take few minutes. One more time, demonstrate how. 3 weeks ago, it was the subject in the content. Already few times demonstrating how to use created. And remember, it was before the Corona trouble, saying that quiz, I asked you to create the model of something and then it is views. Now this is just to call your memory how. Layout. Clicked on Layout tab. Okay, have such a simulation. It is a white paper. And then, well, shall you create the projections, imagining the object as located where? In the first quadrant or in the third quadrant? Well, I'm going to answer both of the questions. How first quadrant, how third quadrant. One more time. When the cursor is on Layout tab, right-click the mouse and select from this menu, it will appear Drafting Standard Setup option with a click. It is to bring this decision dialog box, whether you're going to create the views as first quadrant views or third quadrant. According to select the button. This, if you select this one, then AutoCAD will create the views as first quadrant views. Third quadrant demo, I'm going to click on the other. Okay. First quadrant first. And then I know this paper is in A4 size. I'm going to use A3 size paper, and this decision is also to enable you to make a review on how the size of paper is changed. When the cursor is on layout button, right click the mouse. That case, from the menu select page setup option. And then in this dialog, page setup managing dialog, select modify tab with a click. Okay, and if you're going to, after having the views, you're going to take the print out, then clicking on this list indicate the name of the printer, okay, to say that it is the device, outputting device to send the data for taking the printout. And then from this list select the size of paper, A3 size. Okay, and then plot scale will be 1:1. This means whatever the scale factor for the created views is, then without changing the size of the projections, okay, take the printout. So, well, 1:1 is the correct one. And then clicked on OK. And then close this dialog. Now the paper is in A3 size. And then start the view creation process. You know how. Write this command, view. While writing this word, then, well, you find this list. Select view base option. Firstly created view is called base view. Which view is to be created first? If there will be no sectional view, front view should be created first. Next video record, I'm going to talk about the advantage of creating the front view first. Follow my demo next video record. Select view base option with a click, and then if the model environment there is a solid model, then program will bring this list, drop this list, and then ask us whether gonna create the views for the existing model in model space, or for a solid model it is not in model environment but it is in the memory. If the second one is true, then click on file option and indicate the address of that file, solid model file. But here in this example, for the existing model gonna create the view, so select model space option with a click. And then, well, this simulation, how you can ensure that it is front side? Well, now answer this question. To be able to answer this question, unfortunately, I finished the execution because I forgot to answer this question initially. Well, turn back to model environment and then see. This is the model and that is the orientation cube. Well, this is, you know, in our example, that surface is the most front surface. Saying that this is the most front surface, I said that it is the front side. Okay? Now, my purpose is to create the front side view as the base view. Now see, front side of the model is parallel to that side of the orientation cube. And see, on the surface of the cube, which is parallel to the front side, which word is written? Front is written. To be able to teach to the software that you're going to create the front view, then, well, in the list, in few seconds, you're going to see which list. Well, select the name of that parallel surface of the cube. Here, by chance, it is written front. Although it is written left on this surface, let's say, but it is parallel to the front side of the model, front side of the object, then at the view creation stage, from the list, I would select left option. But here in this example, left side surface of the cube is parallel, front side surface of the cube is parallel to the front side of the object. So to teach to the software that it is the orientation of the object, then from the list select front option. I'm going to select layout, restart the view creation process, view base. And then yes for the existing model, and then yes, orientation. For being sure that which view you're going to create, click on down direction key and from the list select orientation option. And then from this list, the listed ones are the names of the surfaces of the orientation cube. Well, since the surface of the orientation cube, its name is front, is parallel to front side of the model, front side of the object. To be able to create the front view, from this list select front option. But repeat again, if the left side of the orientation cube were parallel to the front side of the model, then I would select left option. But in this example, it's okay, front. Select with a click. Say, I said that is the side of the object. Front side of the object, and that is the simulated one, is the front side view. And then scale factor. Click on down direction key and from the list, in that case, select not orientation but scale option. Well, I see that for the simulated view, scale factor is 1. I check it already. Scale factor 1 to 1 is a suitable scale factor regarding the order of magnitude of the object and the working space of the paper. I am going to use it. Otherwise, I will change the number. Press enter. And then yes, from the learning outcome, say studying on the theory part, you learn clearly, I am sure, that in the first quadrant projection, front view is created not here, drafted not here, not here, not here, but there. If there will be 3 views, front view is to be drafted using this part of the drawing paper. So move the cursor together with the simulated one, simulated thing, it is the view, to this place, and then with a click anchor it. And then, well, finish the base view creation stage, clicking on exit option. And then the rest. Move the cursor in this direction first or in that direction first. Order is not so important. Okay, create the other side views. Move the cursor in this sense, make a click. It is to say that place for the top view. Move the cursor in this direction, make a click. It is to say that the place for the left side view. And then the rest, either press enter or right click the mouse, select enter option. That's it. These are the views. If you couldn't find the views, okay, as balanced on the paper, you know the format requirement. Quickly bring that slide to the screen. Yes, one more time. It is the requirement. B, B, A, A, C is equal to D. Okay, well, 3D environment at the view creation stage, if you couldn't find them as balanced, then make a click on the base view and then find this gripping point and drag the mouse. Okay, making such trials, you can balance the images. Press escape button, click on this and then hold this gripping point. You can move this view to the right, to the left. Okay, to be able to satisfy that format requirement. Line weight button to be able to see the thickness of the visible lines in the realistic order. Yes, clicked on this. If it is off, see the lines as if thin. Clicked on it, make it on, line weight facility. Okay, and then finally, see one more time how the paper simulation is added. For adding the paper simulation margin lines title block, well, you know, I turn back to 2D mode, mechanical option from this list, and then the rest. Well, this is the model. Clicked on layout tab to continue. Yes, along the annotation ribbon, find title border option. Start the process with a click, and from the list select A3 size in this dialog, scale factor 1 to 1. From this select the same scale factor. Under this scale I created the views, and then clicked on OK. And then yes, clicked on close button without doing anything. And then here is the simulation. System asking me where is the lower corner of this simulation. It is to coincide with the corner of this white paper, you know. Bring the cursor to that point and then locate it with a click. And then, well, this typing stage can be skipped, you know, my technique. Using the text facility, starting text typing process can fill in the boxes. Simply say OK. And then yes, that is it. And then system didn't ask anything. Otherwise, I will click on Enter key. Yes, dear students, finish my demo. You see, view creation is relatively much easier than view drawing. This is difficult, this is easier because the views created by the software. In AutoCAD, well, layout button, etc., well, took such things. Model creation takes greater time, view creation greater time, but comparing with the period of time needed to use for view drawing, can say that life is easier in 3D environment. Okay, in Inventor much easier. Okay, ending this video record, my dear students, I think I managed to call your memory how the model is created in AutoCAD, how the views are created in AutoCAD. One more time. I think my demo became fourth or fifth time. And then ending this class work. After the break, well, you're going to see similar things in Inventor. How the model of that object is created and then view creation. Sorry, I forgot to create the third angle projections. Okay, so, well, third angle projection. Save this file. And then I'm going to create the third angle views using the second layout. Okay. And then right click the mouse. And from this list select standard setup, drafting setup. And then select third angle option. And then say OK. Paper, right click, standard setup, say page setup manager. And then, well, 3D, say not 3D, A3 size paper, modify, printer, size of paper. Well, although it is third angle, I'm going to use the paper in A3 size. Okay, in AutoCAD it is so. But in Inventor, yes, selecting British unit system can guarantee to have the papers in standard size in accordance with ANSI. Next video record you're going to see how. But here, okay, plotting scale is 1 to 1 and say okay. And then close this dialog box. And then view creation process. Right view base. View base. Okay. Model for the model. And then, well, front. I already checked that, well, the front side of the cube is parallel to the front side of the object. So from this list, select front option. This is third angle. In the third angle projection, front view is created using this part of the paper. So locate this place, okay, for the front view, and then click on exit button. And then move the cursor in the up direction. It is over there to create the top view. You see AutoCAD knows that we already selected third quadrant, and the things arranged at the background by the software. If I move the cursor in this direction, it is going to be bottom side, but if I move the cursor in up direction, it's gonna be top side. Third angle projection. And move the cursor in this direction, it is going to be not left but right side view. Right click the mouse and then say enter. Yes, this is, first quadrant view set, front top left. This is third quadrant, front top. This is not the left, right side. I'm going to skip the margin line invoking, title block invoking stage. Okay, now, yes, sure, I am ending the record. Bye bye. After the break, can see the things in Inventor. Stop.